Here we are on problem 1116 dealing with traffic collisions. The idea is traffic experts believe that a major cause of highway collisions is the differing speeds of the car. When some cars are driven slowly while other cars are driven at speeds well in excess of the speed limit, cars tend to congregate in bunches, increasing the probability of accidents. So the greater the variations in speed, the greater the number of collisions that will occur. And when that variance exceeds 18 miles per hour squared, the number of accidents will be unacceptably high. That's the hypothesis. So we're going to put it sigma squared is equal to 18 as the null, and then the H1, it's greater than 18. And the idea is, can we conclude at 10% significance level that the variance in speeds exceeds 18 miles per hour squared? So the first thing we're going to do, well, we're going to use a chi-squared test statistic. So we're going to use this formula eventually and do the calculation based on these actual speeds here. But before we do that, we're going to calculate it using this chi-squared function and then do a comparison to see whether we can accept or reject. So first we'll go equal chi chi-squared. Now if we go down here and select this one, it returns the inverse of the right-tailed probability of this chi-squared distribution, which is what we want. Now I double-click there, and it allows us to enter the probability and the degrees of freedom. Well, we know the significant level is 0.10, so that's the probability. And then the degrees of freedom, the sample included 245 cars, so the degree of freedom would be 245 minus 1 is 244. Close the parenthesis, click that, and it's equal to 272.704. So now we're going to use that as comparison with what we actually get based on the data collected. So the first thing we're going to do is, based on those speeds, calculate the standard deviation of those speeds. So to do that, we'll go equal the standard deviation of the sample. So double click there, and the range in this case is going to be A2, and we know there's 245 samples and they go straight down, so it's going to go to A246. And we click the check to enter, and we find out that the standard deviation is 4.75. Well, in this case, what we want is that squared, which is what we need, the s squared up here for the formula. So go equal to this amount, and then we use the little caret above the number 6 to square and put a 2 in there, and we get 22.56 is the variance of the sample, and n is the random sample, the number, which is the 245 cars. So we put that in, and now we can go ahead and do the actual calculation of this chi-squared up here. So we go equals, we go n minus 1 times s squared, the 22.56, and then we actually divide all of that. Let me put another parenthesis in. Divide it by the sigma squared, the 18 in D3. And that gives us 305.8535. So we would, based on the 10% significance and the 244 degrees of freedom, expect that chi-square number to come in at 272, and yet our actual comes in at 305.85 for 18, indicating that it's higher. So based on that, we should be able to conclude that there is enough evidence to infer that the population variance is greater than 18. Now, what happens though if, for instance, instead of the one side of the right tail test here, we've got, say, the HO is equal to 18 and H1, the alternate, is not equal. Then we'd have to do something a little different, and I just want to show you how this would work to do the calculation. So we said the significance level with this was 0.10, but if we were doing it where it was not equal, so we'd have to consider both tails, the left and the right, then we'd have to divide that by 2. So equals that 0.1 divided by 2, 0.05. And once we have that, then the way I want to do this calculation to give you both the high and the low of it would be, and we'll say 244 for degrees of freedom. So I'm going to just use this. Equals chi square returns the inverse of the left-tailed probability of chi-square. So I'm going to put the probability in here of D24 and then degrees of freedom of 244. Hit enter. And that's going to give it to me on the low side. And then equal chi-square, and I'm going to go 1 minus the 0.05 and then put in the degrees of freedom, close it, and we would have a range in here. So the low end would be 208, the high end would be 281, and then we'd have to recalculate the actual based on well, in this case, this calculation would still be fine. It would be using that. In that case, we could not well, let me think about that for pause. So I'm back. With a chi-square actual of 305, we would conclude that that is not equal to 18. If we got a result somewhere between 209 and 281, we would say that there would be enough evidence to infer that it is equal to 18. So I just wanted to, I know it's maybe a little confusing right now, but I'm hoping that I'm showing you how to do it with a two-tail, because your example problem involves that. So if I've confused the situation, send me an email and I'll try and rectify that. But I hope you get the idea that based on the significance and the degrees of freedom, you use the chi-square function to do a calculation, which is the critical value, and then you go through and calculate the actual based on the data you have, and then you look to see from that, do you accept or reject.